Welcome everyone. Guys, in this video, we are going to solve some questions, the most recent questions regarding a drawing of titration curve. So this is the first one. And let's start solving it. We have a 25 centimeter cubic of 0.1 mole decimeter cubic of HCl is added to beaker and its pH is recorded. So we have the beaker here and to it, we are adding HCl. Okay, so guys, usually the concentration of HCl, the pH of HCl is very low. And because we are measuring the pH for this solution, so in the curve, we are going to start from very low pH because this is just a strong acid. Okay, so let me say that we will start drawing from here. And we are adding to it 50 centimeter cubic of 0.1 NH3. Okay, here we are adding NH3. And the question, guys, is how to draw the titration curve. Yeah, how to draw the titration curve for this reaction. If you pay attention, NH3 here is in excess. Look, guys, keep this in your mind. When reactants, both of them have the same concentration, as you see here, HCl and NH3, both of them have the same concentration, right? And both of them, as you see here from this equation, HCl plus NH3 give us NH4 plus Cl minus. Both of them react in the same mole ratio. 1 mole of HCl reacts with 1 mole of NH3. Okay? So 1 mole of this reacts with 1 mole of NH3. And both have the same concentration. So both will react in the same volume. What I mean is 25 centimeter cubic of HCl will react exactly with the 25 centimeter cubic of NH3. This is just keep it in your mind, okay? This is a quick method to understand or to draw the curve to solve the question. But let me show you how could we write this? How could we make sure of this? Okay, how can we understand this is the correct answer for the question? Let me show you something, guys, here. I will start with finding the number of moles of HCl inside the beaker. So we know that number of moles, or sorry, concentration of HCl equal to mole over volume. Mole is X, volume is 25 centimeter cubic. So we convert it to decimeter cubic, then it's going to be this, right? Dividing by 1000. And X, the number of mole of HCl, will be 0.0025. This is the moles of HCl. طيب. As you see here, guys, 1 mole of HCl reacts with 1 mole of NH3, right? So we can write it this way. 1 mole of HCl reacting with 1 mole of NH3. So if I have 0.0025 of HCl, it reacts, let me say, with X of NH3, okay? Cross multiply them. This is a cross multiplication method. I have posted a video like how to deal with the cross multiplication method. You can see it in the channel. By doing this, by applying this, we see that the number of moles of NH3 needed to react with HCl is this. Okay, I will call it Y, sorry, not X, Y. This is the number of moles of NH3 needed to react with HCl. So we have the moles now, and we have the concentration of NH3. So we can find the volume of NH3 needed to react with the HCl. So we say that concentration equal to moles over volume of NH3. Volume will be equal to 0.0025 over 0.1. Okay? So volume will be 0.025 decimeter cubic, which is 25 centimeter cubic. So what I want to show here, guys, that 25 centimeter cubic of NH3 will react completely with 25 centimeter cubic of HCl. Okay? So whenever you have the same mole ratio for the reactants, and whenever you have the same concentration, so both will react at the same volume. 25 will react with 25. 30 will react with 30. Completely, I mean, the completion of the reaction occurs when we add 25 of NH3. I hope you understand this. So look, guys, what will happen now? What will happen now? We are adding NH3 to HCl. So when we add NH3 to HCl, what will happen is the pH will start to increase, right? As you see here in the red line, we are adding NH3, we are adding NH3. No significant change is seen because we still have a lot of HCl. All the NH3 that we are adding completely react with HCl, okay? So as you see here, guys, nothing changes until we reach to 25 centimeter cubic. Give me 1 second. So when we reach to 25 centimeter cubic, we see that at this point, all the HCl inside the beaker reacts completely with NH3. All the HCl reacts completely with the NH3. So the solution now, guys, is no longer acidic. It's jump immediately and it's going to be a basic solution. Okay, it's going to be a basic solution. So this is, guys, the titration curve. The most important thing is to identify where is the vertical line. Okay, this is, guys, the most important thing. And this is how can we find it. First of all, we find the moles of one reactant. We use the equation to find how many moles of the second reactant will react with it. And we find the volume of the second reactant that will react. In this way, we can identify where is the vertical line. Okay, guys, as you see here, the equivalence point of this reaction is not going to be 7. It's almost, let me say, maybe 5 or 5.5. Yeah, it's maybe 6, I think. Okay, something like this, not 7. This is the most important thing. It's not 7. The reason behind this, guys, the reason why the pH, the pH of the equivalence point is not 7, because as we see here in this reaction, when HCl react with NH3, NH4 plus is made. NH4 plus with water can provide us with H3O plus NH3. H3O is acidic. Okay, so the equivalence point is kind of acidic. Yeah. And after adding the rest of NH3, the solution keeps to be more basic. Okay, I hope you understand. This was the first question. So this is the second question. On figure 3.2, sketch the pH titration curve. Yeah, we need to show another titration curve. The first one is 0.1. We are adding 0.1 mole decimeter cubic of NaOH to 25 of 0.1 HBr to excess. Excess of what? Excess of NaOH. So let me show you something here. Inside the beaker, we have HBr. And by the way, HBr is a strong acid. It's mentioned in the previous part of the question. So HBr is a strong acid, and this is given for you, okay? So we have HBr inside the beaker. To HBr, we are adding NaOH in excess, large amount of NaOH, okay? So the most important thing, how to identify where is the vertical line, okay? Is the vertical line on 10, 15, 20? We don't know. So look, guys, NaOH react with HBr, sorry, HBr, to give us NaBr, sodium bromide, plus water. 1-to-1 mole ratio. 1 mole of NaOH reacts with 1 mole of HBr, as you see here. And both of them, HBr and NaOH, both of them have the same concentration. So 25 centimeter cubic of HBr will need 25 of NaOH to react completely, as I mentioned in the previous question. Both of them have the same mole ratio, both of them have the same concentration, so both of them will react in the same volume, okay? I mean, the reaction of them will end at 25 centimeter cubic. When we add 25 centimeter cubic of NaOH, it reacts completely with HBr, so no longer HBr is found in the solution. Let's prove that, okay? So we cannot just draw the answer, draw the curve. Actually, we need to show how did we find this. So let me start with finding the moles of HBr as we did in the previous question. So HBr, look guys, the concentration of HBr is 0.1 equal to X over the volume. The volume will be 0.025. We divide by 1000. So X will be 0.025. Okay? طيب. This is the number of moles of HBr where inside the beaker. And we know that NaOH and HBr reacts 1-to-1. So 1 mole of NaOH reacts with 1 mole of HBr. So if we have, if we have X moles of NaOH to react with 0.025 of HBr, cross multiply them, you will find X equal to 0.025. This is what? This is the moles of NaOH that reacts completely with the moles of HBr. From these moles, I can find the volume. So 0.0025 equal to, the concentration of NaOH is 0.1 equal to 0.0025 over volume. And you will end up with volume equal to 25 centimeter cubic. Okay? This is how can we prove that the reaction or the vertical line will be at 25 centimeter cubic. So here, guys, what will happen is to draw the titration curve, I will, let me erase all of this. We don't need it anymore. HBr, as we said, it's mentioned previously in the question, it is a strong acid. So we start from very low pH. Let me say here, inside the, we're measuring the pH of HBr. So it's going to be very low. And we keep adding NaOH. Now we are adding NaOH. The pH is stable. Titration curve, the titration curve is stable. But at 25 centimeter cubic, here, all of the HBr inside the solution completely reacts with NaOH. So we no longer have HBr, and the curve or the pH jumps immediately, abruptly to a higher value. Sorry for this curve. Sorry, just 1 second. Yeah, to a higher value. NaOH is a strong base, so we expect that the curve jumps to 12 or more, okay? And it will keep go this way. Why is that? Because, sorry, it's not nice curve. Let me say this. Yeah, this is a nice curve. So why is that, guys? Because NaOH is a strong base, so it will have a higher pH. Okay, so this is the curve. طيب. And the equivalence point is supposed to be at pH 7. The equivalence point will be at pH 7. طيب. Let's talk about the second one. 0.1 mole decimeter cubic of NH3 is added to 25 0.1 of HBr to excess. Now we are adding NH3, exactly the same scenario. We know that HBr reacts with NH3 in 1-to-1 ratio to give us NH4 plus Br minus. So 1-to-1. And also, guys, just 1 second. Okay, so as we see here, guys, 1 mole of HBr, 1 mole of HBr reacting with 1 mole of NH3. So the mole ratio is 1-to-1. And we see that both of them have the same concentration, okay? Both of them have the same concentration. So we see that the moles of HBr, okay, or HBr molecules will end when we add, will end completely, will be consumed when we add 25 centimeter cubic of NH3. The volumes are equal, okay? They react in equal volumes because both of them have the same moles and the same concentrations. You can follow my previous steps to solve this, but yeah, now I hope you understand the idea. So when we started drawing the curve, we started from very low pH, and we see that the change or the significant change in pH occurs when we add 25 of NH3. Yeah, the curve, this is the vertical line, but the vertical line will not grow significantly because NH3 is a weak base. Okay, it's not like this, just 1 second. Yeah, let me say, yeah. And we see that the equivalence point is almost at pH 6. This is the equivalence point here. And you know the reason, guys. NH3, we made NH4 plus ions. These ions reacts with water to give us H3O plus NH3. This is acidic, so make the solution or make the equivalence point less compared with strong base. Okay, I hope, guys, you understand this questions. If you have a question, you can write it for me down.